operator in an instrument-filled control room pulls a lever. The vessel tips upright again, and limestone is poured in at the top. Another lever is moved, and down through the top of the vessel comes a long, hollow steel lance. This lance directs a jet of pure oxygen against the surface of the molten mixture, creating a sudden, violent reaction. Unlike the open hearth furnace, there are no gas or oil burners used here, only the jet of oxygen. Smoke and fumes generated by the blow are piped into this huge electrostatic precipitator 4 stories high, the largest smoke control device of its kind in the world. Like a seething volcano, the mixture bubbles inside the furnace for only 30 minutes, refining the molten metal into steel. The vessel is tipped to the other side, and into a ladle below goes more than 100 tons of high-quality steel. Molten steel is poured into big cast iron molds, forming ingots which weigh from 4.5 to 20 tons. When the ingots have cooled inside their molds, the heavy casting is stripped off, and the ingots are taken to a reheating furnace called a soaking pit. And that basically is the story of how steel is made, starting from this piece of iron ore. You can see why this ore is discarded as worthless by the old prospectors. They couldn't have dreamed of the giant furnaces and machinery used in today's steel-making processes. But making steel is only half the story. The other half is forming the steel into final, usable shapes. Do you remember the old-fashioned clothes wringer? Well, steel rolling mills work about the same way. Massive rolls squeeze together while the hot steel is forced through, flattening it, shaping it, or forming it. At Fontana, there are 9 separate rolling mills, each located in its own building. But the starting point for all of these mills is a glowing hot ingot, taken from the soaking pit when it is hard enough for easy handling, yet soft enough to be shaped by the big rolls. Skilled operators keep it moving, each squeeze through the rolls tighter than the one before. Back and forth it goes a dozen or more times. All steel undergoes this initial step to get it into sizes that can be handled by the other specialized mills, which roll the steel into the hundreds of different steel products required by Western industry. Steel for bridges, freeways, storage tanks, railroad cars is made in the plate mill. Steel for automobile frames, truck bodies, drums, and water heaters is rolled in the hot strip mill in a building a half-mile long. The steel goes through 11 separate rolling stands in less than 2 minutes' time. It winds up spinning in a coil of steel sheet more than a quarter of a mile long. Steel for kitchen appliances, office equipment, aircraft parts, and bicycles is produced in the cold roll mill. Steel for office buildings, factories, towers, schools is produced in the structural mill. Back and forth it goes, as many as 11 times, until the final shape is achieved. Steel for automobile springs, bumpers, farm implements, hardware is produced in the merchant scalp mill. Small diameter pipe for plumbing, playground equipment, sprinkler systems, signposts is manufactured in the continuous weld pipe mill. This mill produces enough plumbing pipe every 8 hours for 500 average-sized homes. Larger pipe for gas lines, water lines, refineries, pilings is manufactured in the electric weld pipe mill. A continuous strip of steel sheet is formed into a cylinder and welded in a continuous operation. Steel with a super thin coating of tin for tin cans to preserve food, and for thousands of other uses, is produced in the tin plate mill. Thin steel sheet rolled into a coil, softened, then coiled again. A final process applies a thin coating of tin by electrolysis. Actually, tin plate is more than 99% steel, less than 1% of tin. These are the buildings and the machines that make steel, that roll steel. But more important than all of these are the people who make the steel. True, machines are necessary, but it is people who design them, who run them. Men with the blueprints for tomorrow. Men using new machines and new techniques. Welders, office workers, men who sell the steel. Men who wear grotesque clothing. Men who work miles under the earth. And men who live well while they work in the rugged mountains of Sunnyside, Utah. Men who bring their families to places like Eagle Mountain, California. Out-of-the-way places once covered with sagebrush, now modern communities in a resort-like climate. Men who fabricate steel to form the muscles, the backbone of the modern West, making aqueducts for thirsty cities, fabricating huge tanks to store the fuels of modern living, and form miles of pipe to bring them from faraway places. Skilled craftsmen shape steel into pressure vessels, massive girders to span rivers, barges, stadiums, floating towers so tall they must duck their heads to pass beneath the Golden Gate Bridge. Missile stands from which men may reach out to the wonders of space. Yes, this is the story of steel. From the mines to the furnaces, from the rolling mills to the market. This is the story of an industry that laid a foundation for the building of the future. It is a story that began 100 years ago, when bearded prospectors searching for precious gold picked up a reddish-brown rock, then threw it down again, never dreaming that from the forgotten ore of Eagle Mountain would come the #1 metal of our time.